Okay, my dear students. So last time, as you know, that we had started with the experimental chemistry. Uh, we had done with the mass, volume, temperature. Okay, all these stuff. So today we are going to start with the collection of gases. That how you people could collect the gases. So collection of gases. Okay, my dear students, if you want to collect the gas, how should you collect it? There are the three steps you have to follow for the collection of gases. Any gas could be collected by a gas range, all the gases. Okay, but if you want to you want to collect the gas in the gas cylinder, which is made up of glass. Okay, so how could you collect it? So there are the three steps. The first step, when you want to collect the gas, the step one, that is you have to see the color of gas. Okay, so this is the step one. You have to see the color of the gas. So there are the two possibilities, beta. The first possibility, the gas could be colored, and the second possibility, the gas is colorless. Okay, so if the gas is colored, okay, so if you are going to collect the gas in the gas cylinder, that is actually a cylinder which is made up of glass. It's a clear glass, you can see anything inside it. Okay, so if the gas is colored, so the gas would be collected within that particular gas cylinder, and you can see the color of the gas inside it because this one is made up of glass. Okay, so you come to know that this gas is present inside it. Why? Because the cylinder would become brown color, yellow color, whatever the color of the gas that would be. Okay, so the uh, colored gases, keep remember, they are normally the three. The first one, that is NO2. Okay, so NO2 gas, that is brown in color. Okay, so if you collect the nitrogen dioxide, NO2 gas, the color of the gas cylinder would become brown. The second option, that is chlorine, that is the greenish yellow gas. Greenish yellow. Okay, and the next one, that is fluorine, that is pale yellow. Okay, so these gases, my dear, they are the colored gases. If you are going to collect these gases in the gas cylinder, so what would happen? The color of that gas cylinder would become either brown if it is NO2, it would be greenish yellow if the gas is chlorine, it would be pale yellow if the gas is fluorine. You got it?
Yes, sir.
Yes, sir.
But
Yes, sir.
okay, my dear, if the gas that is colorless gas, okay, so you people are unable to see that whether the gas is collected or not because the gas is colorless. If you see around, the air is present, air is colorless, you are unable to see the air. Okay, so if the gas that is being present within the gas cylinder, it is colorless, so you are unable to see whether the gas is collected or not. So then you have to move towards the step two. For colorless gas, you are going to collect it, you have to move towards the step two. Okay, and what is the step two? Step two, in step two, you have to check the solubility of gas. Okay, so there are the two possibilities. Okay, the first possibility, that the gas that is uh, soluble in water, and the second possibility, that the gas that is insoluble in water. Okay, Okay, if the gas that is insoluble in water, okay, so then what should you do? You have to collect the gas by a method which is called as the displacement of water. Okay, but if the gas that is soluble in water, then you have to move towards the step 3. Okay, so firstly, what is the displacement of water? I'm going to tell you about it. What is the displacement of water? Just listen it very carefully, guys. Have a look. uh, let's suppose uh, this is the place where the gas is being produced. Okay, so you should take a tube from here like that. Okay, and now you have got uh, this is the gas cylinder. This is the gas cylinder. It is made up of glass. It is a clear glass. You can see across it. Okay. Now, what should you do? You should fill this gas cylinder with water from up till the top. So this is the gas cylinder. You should fill it with water. Okay. Now, what should you do? You should take a tub of water like that. So this is the tub of water. So this is also containing water inside it. Okay. Now this tub has got a thing like that, which is having the two holes inside it. One hole is present up here, one hole is present up here. Okay. So now what should you do? You should invert this gas cylinder up till here like that. So the gas cylinder should be inverted like that. So what would happen? The water level that will drop and it will remain at a particular position up here like that. So the water is present up here. So this is the water. Okay. Now the place from where the gas is being produced, just put it up there like that. Okay, so what would happen? The gas producing from here, it will go from this tube, goes up here because this gas is insoluble in water. So it will rise up, it will come up here, it will be accumulated at that place. And now what would happen? The level of the water that will drop from here. So this level of water that is going to drop from here like that. It will drop like that. So this empty space, that is going to show that the gas is being collected up here. So you can see the gas collecting by your eyes when the water level is going to drop from here. You got it? So this method, that is called as the displacement of water. Is it clear,
Yes.
Yes.
guys? Okay. So this is your step 2. Okay, so I'm going to repeat my whole stuff. Whenever you want to collect the gas in the gas cylinder, not in the gas range, in the gas range you can collect any gas, even it is colored, even it is colorless, whatever. Okay, because the piston will start moving and it will tell you that the gas is being collected in it. But if you want to collect the gas in the gas cylinder, you have to see first, in the first step you have to see the color of the gas. If the gas is colored, it would be easy for us to collect the gas. Okay, because the gas cylinder would become brown in color if NO2 is being collected. The gas, the color would become greenish yellow if the gas is chlorine. The color would become pale yellow if the gas is fluorine. But if the gas is colorless, you people are unable to see that the gas is collected or not. Then you have to move to the step 2. In the step 2, my dear, you have to see the solubility of gas. Gas may be soluble in water, gas may be insoluble in water. If the gas is insoluble in water, okay, so whatever the gas is, you have to collect it by the displacement of water. And in the displacement of water, gas cylinder which is filled with the water is inverted in a tub of water like that. So the gas will be introduced from the base of this hole as the gas is insoluble in water, so it will rise up and will be collected up here, and it will press the water level, and water level will come down. So you will see that the gas is being collected at that empty place. So this is called as the displacement of water.
Excuse me, sir.
Yes, yes, beta.
सर ये डिस्प्लेसमेंट ऑफ वाटर एक दफा फिर बताने समझ नहीं आ रहा.
यार इसमें कोई मुश्किल नहीं है भाई, आपने ये गैस सिलेंडर ले लेना है, ठीक है, इसको पानी से भर देना है, और एक ये टब ले लेना है, इसको पानी से भर देना है, और ये इसके अंदर एक कप पड़ा हुआ है जिसमें 2 सुराख हैं। ये जो आपने पानी से भरा हुआ गैस सिलेंडर है, इसको उल्टा कर देना है यहाँ पे, ठीक है। तो इसमें पानी का लेवल जो है वो कहीं पे स्टे कर जाएगा। अब यहां से जब गैस यहाँ पे आएगी तो वो पानी में इनसॉल्युबल है, वो ऊपर राइज करेगी, तो ऊपर खाली जगह पे आके वो इस पानी के लेवल को प्रेस करेगी, पानी नीचे आता जाएगा, तो यहाँ पे गैस कलेक्ट होती जाएगी। पानी का नीचे आना शो करता है कि गैस कलेक्ट हो गई है। यू गॉट इट?
यस सर.
थैंक यू। Okay, my dear, the next step, that is the step 3. In the step 3, you have, if the gas that is soluble in water, so if the gas will come, if you are going to collect the gas by the displacement of water, because the gas is soluble in water, it will dissolve within the water, it won't be collected up here, then you have to move towards the step 3. Can I move to the next page, beta?
Yes, sir.
Yes.
Yes, sir.
Okay, my dear, the last step for the collection of gas, that is step 3. Okay, in the step 3, you have to see the density of the gas. Density of gas. So this is very important, my dear. Density of the gas. The gas is of 2 types. The first thing, gas is less dense, or lighter. Okay, and the second option, the gas that is more dense or heavier. Okay, so what is meant by the less dense or lighter, more dense or heavier? It means you have to calculate the MR. Okay, if the MR of gas is less than 28, so it is lighter. And what is meant by the more dense? If the MR of gas
Sir,
is,
why 28?
sorry,
सर 28 ही से क्यों हमने कंपेयर करना है?
मैं बताता हूं बेटा, मुझे अगर आप थोड़ा सा टाइम दें, आई एम गोना टेल यू अबाउट इट, डोंट यू वरी. If the MR of gas is more than 28, okay, my dear students, so what is first of all meant by the word MR? Okay, let's suppose we have got the 2 gases, CO2 and the second gas, that is NH3. Okay, now if we want to calculate their MR, how could we calculate it? In the paper, periodic table is being given. So what should you do? You should open up the periodic table, have a look where C is written. Okay, and have a look where O, oxygen, is written. So it has got the 2 numbers with it. The bigger number, that is called as the AR. Okay, so carbon is having the AR 12. Okay, so you should write 12 up here. It has got just 1 atom, so times 1. And oxygen, that is having the AR, the bigger value, that is called as the AR 16. So 16, how much atoms are present? 2, so times 2. So just calculate it, it would become 44. Okay, and just like that, NH3, if you open the periodic table, N and H, with N you have got the 2 numbers 7 and 14, with hydrogen you have got 2 numbers 1 and 1. These are provided you in the periodic table. Okay, so for nitrogen, the AR, that is 14. Nitrogen has got just 1 atom, so multiply it with 1. and hydrogen, it has got 1. So how much atoms are present? 3. So times 3. So it would become 14 plus 3, that is 17. You got it? So this is how you can calculate the MR. Now the thing is, why we have said that the MR is less than 28, then that would be lighter, because air, my dear, air is composed of nitrogen, which is almost 78%, and the MR of nitrogen, my dear, nitrogen has got the 14. So 14, so 2 times mean 2, so it would be 28. So the MR of air, that is considered to be 28 almost. Okay. So if any gas having MR less than 28, so it is lighter than air. The word lighter mean lighter than air. Okay. Denser mean denser than air, more denser than air. So we are going to compare it with respect to air. So lighter or less dense mean it's lighter than air. You got it? Everybody got it, beta? Why I have told you 28? Air has got the MR value 28. If the MR that is less than 28, so the gas that is lighter, that is less dense. You got it?
Yes, sir.
Okay, guys.
Yes.
I'm going to rub little bit things from here. Just take a screenshot of it, please.
Done, sir.
Okay. Okay, my dear students. So if your gas that is uh, soluble in water, then you have to collect it by having uh, uh, by having look at the density of the gas. The gas could be less dense than air, or it would be more dense than air. Air has got the MR 28. Okay, so if the gas is lighter or less dense than air, then you have to collect it by upward delivery. Okay, what is the upward delivery? Let's suppose if this is the system by which the gas is being produced. Okay, so you should take, so you should invert the gas cylinder like that, because the gas is lighter. It is very lighter, so it will rise up. So this place, you should take the gas cylinder in the inverted position, and the gas, it will rise up. So there is a place which is which will stop it from going up. Okay, so the gas would be collected. So this method, that is called as the upward delivery. Whereas the gas, if it is more denser than air, you can collect it by downward delivery. By downward delivery. And what happens in the downward delivery? In the downward delivery, let's suppose if this is the system by which the gas is being produced. Okay, so you should put the gas cylinder in that position like that. Okay, so you should put the, this is the gas cylinder. Gas cylinder. This is the gas cylinder in inverted position. So this method, that is called as the upward delivery, and this method, that is called as the downward delivery. As the gas that is heavier, so the heavier thing will sink down. It will sink down. Okay, it is not going to rise up. So it will sink down. So you can collect the gas by putting a gas cylinder in normal position. You got it?
Yes, sir.
Yes, sir.
Okay, guys, take a screenshot of it. Can I move to the next page?
सर
Yes, sir.
Yes, beta.
सर जो कलर्ड गैसेस हैं क्लोरीन ब्रोमीन जो है सर वो कैसे कलेक्ट होंगी?
बेटा उनको तो वैसे ही बताया है, गैस सिलेंडर में कलेक्ट कर लो, जो कलर उनका है वही गैस सिलेंडर का कलर हो जाएगा, क्योंकि ग्लास सिलेंडर आपका शीशे का बना होता है जिसके क्रॉस आप देख सकते हो, तो वो कलर सारा उसी गैस सिलेंडर का हो जाएगा, तो आपको पता चल जाएगा गैस कलेक्ट हो गई है।
सर उनके लिए हमें उनकी डेंसिटी फाइंड करने की जरूरत होगी ताकि हम ये पता लगा सकें
नो
अपर
माय डियर, इफ द गैस इज कलर्ड, जैसे मर्जी सिलेंडर रख के गैस उसमें एंटर करो, वो सारे वो कलर्ड हो जाएंगे यार।
जी सर।
आप जो गैस सिलेंडर यूज कर रहे हो वो शीशे का कर रहे हो, क्लियर है, उसके अंदर से आपको चीजें नजर आती हैं। अगर तो गैस दैट इज कलर्ड, तो वो कलर आपका पूरे का पूरा गैस सिलेंडर का हो जाएगा, आपको पता चल जाएगा गैस कलेक्ट हो गई है। इफ द गैस इज कलरलेस, देन यू हैव टू मूव टुवर्ड्स स्टेप 2 और स्टेप 3। स्टेप 2 तब यूज करते हो जब गैस इनसॉल्युबल है। इनसॉल्युबल है तो उसको डिस्प्लेसमेंट ऑफ वाटर से आप कलेक्ट कर लो, लेकिन अगर गैस सॉल्युबल है देन यू हैव टू सी द डेंसिटी ऑफ गैस, उसका एमआर निकालो। अगर उसका एमआर 28 से कम है, then you collect it by the upward delivery, and if the MR that is more than 28, then downward delivery.
ओके सर,
Okay,
थैंक यू वेरी मच।
okay, my dear students, now we are going to start with the last thing of this thing, different drying agents. Drying agents for gases. Okay, normally, my dear, if you people are going to collect the gases, so normally water vapors, they are normally present within those gases. So if you want to clear the water vapors from the gas, so there are some drying agents. So different gases have got different drying agents. Okay, the first thing, if the gas that is a basic gas, okay, or which it is also called as the alkaline gas. Okay, so the basic gas is only one, that is ammonia, NH3. No gas in this world is basic except for ammonia. Okay, so for drying, for the basic gas, the drying agent that is also a base, it is calcium oxide. I have told you the metal oxides, they are basic in nature. So calcium oxide, that is also basic. So the base do not react with the base. Okay, so if you pass the ammonia gas from the calcium oxide is base, so ammonia is a base, so base doesn't react with the base. So this is a drying agent, it will absorb all the water vapors present within the ammonia, and your gas that would be dried. You got it, guys?
Yes, sir.
Yes, sir.
Okay, guys, the second thing, that is acidic gases. To dry the acidic gases, what are the acidic gases? The first one, that is carbon dioxide, it's an acidic gas. Sulfur dioxide, sulfur trioxide, then nitrogen dioxide. Okay, so all these gases, HCl gas, so all these gases, they are actually the acidic gases. If you want to dry these acidic gases, the drying agent we use, that is also acidic, and that is concentrated sulfuric acid, H2SO4. Okay, for acidic gases you use the drying agent acid. Okay, for basic gases, don't use concentrated sulfuric acid. Why? Because ammonia is a basic gas, it could react with the acid. Okay, for acidic gases use acid, for basic gases use basic drying agent. Okay, so what would happen if these gases have got the water vapors inside it, if you pass them through the concentrated sulfuric acid? So concentrated sulfuric acid is a drying agent, it will absorb the water vapors, and these gases, they would become dry. You got it?
Yes, sir.
Yes.
Can I move to the next page, beta?
सर ये गैसेस को ड्राई करते क्यों है?
जी बेटा, क्या कह
ये
रहे हो?
गैसेस को ड्राई कर
जी जी, ड्राई करने के लिए इस्तेमाल कर रहे हैं बेटा, ये ड्राइंग एजेंट, ये जो मैं आपको नाम बता रहा हूँ।
नहीं, लेकिन
अच्छा जी,
सर इन्हें ड्राई करने का क्या फायदा होगा?
सॉरी क्या कह रहे हो बेटा?
इनको ड्राई करने का क्या फायदा होगा?
ड्राई करने का क्या फायदा होगा? बड़ा फायदा है यार। आपको पेपर में वो अगर कहते हैं कि कोई गैस जो है आपने कलेक्ट करनी है ड्राई फॉर्म में, तो उसमें वाटर वेपर्स नहीं होने चाहिए, देन यू हैव टू यूज द ड्राइंग एजेंट।
ओके सर।
तो ड्राइंग एजेंट अगर आपको पता होगा तो आप यूज करोगे ना। ओके माय डियर।
हम जो भी जब गैस कलेक्ट कर लेंगे जिस भी मेथड से, हम उसे बाद में ड्राइंग एजेंट में से पास आउट करेंगे।
जी सर, एग्जैक्टली माय डियर। सबसे पहली चीज यही जेन में रखनी है कि ड्राइंग एजेंट में से पास करके गैस को कलेक्ट करना होता है। ओके माय डियर, then last thing, that is the neutral gases. Neutral gases which are not acidic, which are not bases. Okay, what are the gases which are neutral? Hydrogen gas, that is neutral. Okay, ethene, that is neutral. Okay, just like that, nitrogen, that is neutral. Okay, so all the gases, my dear, which are neutral, if you want to dry them, okay, so the drying agent for neutral gases, that is anhydrous calcium chloride. Calcium chloride is a salt. Okay, calcium chloride, and its formula is CaCl2. Okay, so this is the drying agent that is being used to dry the neutral gases. So keep remember, my dear, whenever you want to collect a gas, first of all you have to see whether the gas is acidic, basic, or neutral. If the gas is acidic, you have to use concentrated sulfuric acid as a drying agent. If the gas is basic, you have to use calcium oxide as a drying agent. But if the gas that is neutral, you have to use the anhydrous calcium chloride as a drying agent. Okay, uh, can we move to the next page, beta?
Yes sir.
Yes, sir.
Okay, my dear students, now we are going to start with the uh, pure substance. And anybody could tell me what is the pure substance?
There is substance that does not have any unwanted
There's zero impurities on जिसमें.
Does not have any
impurities.
impurities.
Okay, my dear students, keep remember, let's suppose if this is the beaker, if I'm going to say you that it contains pure water, so water mean H2O, so it only contains H2O inside it, nothing else. But if something else is present like sodium ion, chloride ion, like that, so these things, they are the impurities. So pure substance actually contains the particles of the same kind particles are present, so that is actually called as the pure substance. If more than one kind of the particles are present in a substance, that is the impure substance. Okay, so a substance having particles of same kind is called pure substance. Okay, the next thing that should be keep remember, my dear, keep remember that the pure substance, they have got sharp melting and sharp boiling point. Sharp melting and sharp boiling point mean that if you are going to melt a pure substance, okay, if it is in solid state, so when its melting point would be reached, the temperature would become constant until whole of the substance that would be melted, the temperature won't increase. Okay, so its melting points, let's suppose it's 20 degrees Celsius, 40 degrees Celsius, so it is consisting of only one number. Okay, so this one number is going to show it has got sharp melting and sharp boiling point, whereas impure substance, they have got range of melting and range of boiling point. Like the thing is going to start melting at 20 and 23 degrees Celsius. So this is the range. So this range is going to show that this substance is not pure. Okay, pure substance have got their sharp melting point only one number, 20. That's it. Okay, if its melting point is 20, so the temperature would remain 20 until whole of the substance that would be melted. So this thing is called as the sharp melting point. So this is sharp, and this thing 20 to 23, this thing is going to show you the range. Okay, so keep remember, my dear students, that the pure substances have sharp melting point and sharp boiling point. Sharp melting point and sharp boiling point mean it consists of only one number. I've just written one number up here like that. Okay, and here I have got I'm going to write one number only, just melting point, that is suppose 40 degrees Celsius. Okay, like that. Whereas impure substances, they have got range of melting and range of boiling point. Okay, so impure substances have range of melting point and range of boiling point. Range of boiling point mean, let's suppose it's 60 degrees Celsius to 64 degrees Celsius, like that. This is the range. Okay. And the range up here, let's suppose 40 degrees Celsius to 43 degrees Celsius, like that. Okay, so anything which is impure, it has got its melting or boiling point in a range. So it is going to let's suppose it's going to boil at 60. Okay, and the temperature will go on increasing up till 64 when it is boiling. But in case of pure substance, when the substance will start boiling, the temperature is 52, it would remain 52, it won't increase. Okay, if the substance that is pure. Is it clear, beta? Everybody got it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, my dear students, let's pose. Can I move to the next page? Okay, dear. Let's suppose you people have got a pure substance. Okay. And this pure substance has got sharp melting and sharp boiling point. Let's suppose its melting point, that is 40 degrees Celsius, and its boiling point, that is 120 degrees Celsius. Okay, so this sharp melting point, one number melting point and one number boiling point, that is going to show it is a pure substance. Okay, so you have got a pure substance. Now what you are going to do, if you add any impurity inside the pure substance, add impurity. Okay, any impurity you are going to add inside the pure substance. So what this impurity that is going to do, it is going to make its melting point
Varies.
low. Okay, and its boiling point high. So let's suppose firstly its melting point was 40 degrees Celsius. Now it would become less, it would become 36 degrees Celsius. Okay, and its boiling point, firstly it was 120, so now it would be 124 degrees Celsius or 123. It's not necessary that you should increase this by 4. 123, 124, depending on the amount of impurity you have added inside it. So
Sir,
keep remember.
question.
जी बोलिए.
सर हमने जब एक प्योर सब्सटेंस के अंदर इम्प्योरिटी डाली तो उसकी जो मेल्टिंग पॉइंट था वो वेरी क्यों नहीं किया जैसा पिछले इम्प्योर सब्सटेंस का होता है.
मैं आपकी बात को फॉलो नहीं किया. व्हाट आर यू आस्किंग?
सर मेरा मतलब है कि अभी हमने आपने बताया था कि इम्प्योर सब्सटेंस जो होती हैं उनका कोई फिक्स्ड ये नहीं होता कि इसी
जी जी
पॉइंट पे
बिल्कुल
आके
फिक्स नहीं
मेल्ट
होता।
करेंगे।
तो ये 36 जो मैंने बताया यहाँ से इसका मेल्टिंग पॉइंट शुरू होगा, तो लेकिन ये 36 पे रुका नहीं रहेगा। जब ये मेल्ट हो रहा होगा तो 36 से 38 तक चला जाएगा या 40 तक चला जाएगा। वो
ठीक
रेंज
है सर।
ऑटोमेटिकली बन जाती है बेटा, लेकिन कम हो जाता है। ओके, इसकी मैं आपको एग्जांपल, आई एम जस्ट गिविंग यू वन एग्जांपल इन अवर डेली लाइफ। आप लोग इफ यू टेक द वाटर, प्योर वाटर को इफ यू आर गोइंग टू बॉयल इट, so it will boil at 100 degrees Celsius. That is its boiling point, or its melting point is 0 degrees Celsius. Okay, water की बात कर रहे हैं. If you are going to add salt inside it, इसके अंदर salt add कर दें और उसको आप लोग जो है वो अब उसको मेल्ट करें यानी उसकी बर्फ बना के, तो वो 0 डिग्री सेल्सियस पे मेल्ट नहीं होगा. इट इज गोइंग टू मेल्ट एट -4 डिग्री सेल्सियस. उसका मेल्टिंग पॉइंट कम हो जाएगा, बॉइलिंग पॉइंट उसका ज्यादा हो जाएगा. इफ यू आर गोइंग टू बॉयल इट, it will not boil at 100 degrees Celsius. It will boil at a temperature more than 100, 102, 103 degrees Celsius. You got it,
Yes, sir.
guys? Okay, so this is the
Yes
rule.
sir.
Whenever you are going to add impurity in any substance, okay, in any pure substance, so keep remember its melting point would be lowered, but that melting point is not sharp. It would be range. It will not remain like at 36. It will start moving towards 38. Okay, so why? Because it is the impure substance, they have got range of melting and range of boiling point. Okay, guys. So that's it for today. So tomorrow we are going to start with the methods of purification. Okay. Uh, any question relating whatever we have done today, you can ask me. And please pray for me as well. I have got high fever, cough, and all these stuff.
जी sir.
Okay, guys. Have a nice time. Take care of yourself. Allah Hafiz.